Here's a thought experiment for you. Imagine a car manufacturer that, for every new model they release, kept all the parts from every previous version of the car, including parts from horse-drawn carriages, parts from steam-powered prototypes, parts from models that were discontinued 80 years ago, and just left them in the vehicle, not doing anything, not connected to anything important. Just riding along, taking up space, occasionally causing problems, stubbornly present because removing them wasn't worth the engineering effort. You would consider that manufacturer insane. And yet, that is, with remarkable precision, what evolution has done to you. Your body is carrying parts from previous versions of the human design, previous versions of the primate design, the mammal design, the vertebrate design, that have lost their original function across millions of years of changing conditions, but that haven't been cleanly removed because evolution doesn't run quality control sweeps. Evolution only removes things when maintaining them costs more than losing them. If a useless structure isn't actively killing you before you reproduce, evolution is largely indifferent to its presence. The result is a body that is, underneath its genuinely impressive engineering, also a museum of biological obsolescence. You are walking around with anatomical artifacts. Vestigial structures, the technical term for body parts that have lost their ancestral function through evolutionary change, are present in your body right now, some visible, some internal, some microscopic, some that you've probably noticed without knowing what you were looking at. This is their story, and it is, once you start pulling at the thread, considerably more extensive and more interesting than the short list most people carry. Start with the one that almost everyone knows because it's the gateway drug to this entire topic, and because the common understanding of it, while correct in outline, misses most of what makes it interesting. The appendix, the vermiform appendix, worm-shaped appendix if you're translating the Latin, is a small, finger-shaped pouch attached to the cecum at the junction of the small and large intestine. In humans, it has no clearly established digestive function. In your herbivorous mammalian ancestors, the cecum and its appendix-like extension were large fermentation chambers that housed bacteria capable of breaking down cellulose in plant material. As the human lineage shifted away from heavy plant matter dependence, the cecum shrank. The appendix remained smaller, functionless in the digestive sense, and occasionally disastrously inclined to become infected and rupture. Appendicitis kills people. A vestigial organ with no significant function manages to be the source of a medical emergency that, before surgical intervention was available, was frequently fatal. The appendix is the vestigial structure with the best PR for being useless and the worst behavior for confirming it. Here's the nuance. More recent research has complicated the completely useless narrative. There's evidence that the appendix may serve as a reservoir for beneficial gut bacteria, providing a protected space from which the intestinal microbiome can be repopulated after illness-induced depletion. If accurate, this would make the appendix not entirely vestigial in modern humans, a reduced, repurposed version of its ancestral function rather than a complete non-participant. Whether this represents a meaningful current function or a trivial secondary use that doesn't justify the appendix's continued dangerous existence is genuinely debated. But the core evolutionary story stands. The appendix is present because its ancestral form served an important digestive purpose, and that purpose largely disappeared while the structure remained. You are carrying intestinal infrastructure from a dietary strategy your lineage mostly abandoned millions of years ago. The coccyx is more visually and conceptually obvious once explained, and it is sitting at the base of your spine right now, doing almost nothing. The coccyx, the tailbone, is a series of fused vertebrae at the terminal end of the human vertebral column, typically 3 to 5 segments fused into a single structure. It is the remnant of the tail that your primate ancestors had, and before them, the longer tails of earlier mammals, and before them, the elaborate tails of more distant vertebrate ancestors that were essential for balance, locomotion, and communication. The last common ancestor of humans and other great apes was tailless. The taillessness of humans and the other great apes is an ancestral characteristic of the hominoid lineage, not something humans evolved independently. But before that tailless ancestor, there were tailed primates, and the coccyx is the skeletal trace of that evolutionary heritage, maintained as a vestige because the tail vertebrae didn't disappear entirely. They just stopped extending beyond the body, stopped being distinct and mobile, and fused into this small, tucked-away structure. The coccyx does have some current functions that prevent it from being pure non-participant. Muscles of the pelvic floor attach to it, and it plays a role in weight distribution when sitting. So it's a vestige that has been partially co-opted for other functions, which is how evolution often handles its leftovers. Not clean elimination, but functional reassignment. But it's clearly not doing what ancestral tail vertebrae were built to do. It is, structurally and developmentally, a tail that stopped being a tail. Occasionally, human infants are born with an extended coccyx that protrudes beyond the body surface. A soft tissue tail, sometimes with muscle fibers, sometimes with cartilage or bone extension. These are surgically removed shortly after birth, typically without complications. They appear in roughly 1 in every few tens of thousands of births, representing cases where the developmental program that normally keeps the coccyx internal and truncated is somewhat less strictly enforced. The program is still there. The tail-making developmental machinery is still present in human development. It just usually stops where it's supposed to stop. Usually. The plantaris muscle is present in the lower leg of roughly 80 to 90% of humans. A small, thin muscle with a very long tendon running down the back of the lower leg, from the lower femur to the heel. In other mammals with similar muscles, the plantaris serves for gripping. In species that use their hind feet for climbing or grasping, this muscle contributes to plantar flexion and toe manipulation. In humans, whose feet are walking platforms rather than grasping appendages, the plantaris does almost nothing. Its contribution to plantar flexion is minimal, and its absence creates no measurable functional deficit. The plantaris is so reliably uninvolved in essential function that surgeons routinely harvest its tendon for use in reconstructive procedures elsewhere in the body, repairing tendons in the hand, wrist, and other locations, because removing the plantaris tendon from a patient creates no meaningful loss of lower leg function. The patient heals, performs physical therapy, and their leg works the same as before. They have donated a vestigial tendon to repair something more important, and the leg had nothing useful to say about the loss. In the 10 to 20% of people who don't have a plantaris, a common anatomical variation, studies confirm that their lower leg function is identical to people who do have it. If having versus not having a muscle makes no difference to the outcomes the muscle was supposedly participating in, the muscle's claim to functional relevance is difficult to defend. The palmaris longus, already discussed in another context, deserves revisiting here specifically as a vestigial structure rather than a variation. Present in roughly 85% of humans, absent in 15% with no functional consequence, the palmaris longus is a forearm muscle whose contribution to wrist flexion in humans is negligible. In non-human primates and other mammals where it's present and well-developed, it contributes to gripping and climbing behaviors. The manipulation of branches and other surfaces with the hands in ways that require sustained forearm tension. Human hands grip differently from primate hands adapted for arboreal locomotion, and the palmaris longus's function in that original context doesn't translate cleanly to the tasks modern human hands perform. The muscle persists because it's not costing enough to maintain to trigger its evolutionary removal. And in the meantime, surgeons have found it useful as a graft source for the same reasons as the plantaris. Reliably present, reliably inessential, reliably harvestable. The erector pili muscles are perhaps the most democratically experienced vestigial structures, because their effect is something you've felt your entire life without necessarily knowing what caused it. These are the tiny, smooth muscles attached to the base of each body hair follicle. And when they contract, triggered by cold or emotional stress through the sympathetic nervous system, they pull the hair follicle upright, creating the small raised bumps at the base of each hair called goosebumps. In mammals with thick fur coats, this response is genuinely functional. Raising the fur creates a thicker insulating air layer, retaining body heat more effectively. The same principle as a puffer jacket, trapping air for insulation. In threatening situations, raised fur also makes the animal appear larger, which is useful for deterrence of predators or rivals. The response is immediate, automatic, and in a furry mammal, meaningfully effective. In humans who have largely lost the thick body hair coating that would make this response effective, the erector pili keep working. The sympathetic nervous system stimulus comes in. The muscles contract. The remaining small body hairs stand up. The raised skin bumps appear. The insulating benefit is negligible because there's not enough hair to trap meaningful air. The intimidation benefit is negligible because the human silhouette doesn't change meaningfully with body hair erection. The goosebump response accomplishes essentially nothing and then subsides. You have experienced goosebumps thousands of times in your life. Each time, muscles in your skin worked, creating a response that would have been useful to your hairy mammalian ancestors, and that currently achieves approximately nothing. The machinery is fully intact. The output is vestigially irrelevant. Third eyelid remnants are less commonly discussed, but arguably more surprising when first encountered. In the inner corner of each human eye, the medial canthus, the small, fleshy pink triangle, there is a structure called the plica semilunaris, a fold of conjunctival tissue. It is the remnant of the nictitating membrane, the third eyelid that is fully functional in many other vertebrates. A fully functional nictitating membrane sweeps across the eye horizontally from the medial corner, providing a transparent or semi-transparent protective cover that clears debris from the eye surface, maintains moisture, and protects the eye while still allowing visual function. Birds use their nictitating membranes constantly. You can see them in slow-motion footage of birds of prey striking targets, the white membrane sweeping across the eye a fraction of a second before impact. Many reptiles, fish, and other mammals have functional nictitating membranes. Cats and dogs have partial versions. By the way, if you want to go even deeper into the secret lives of ancient humans, I just launched a full course called The Secret Lives of Ancient Humans. 10 modules, 3+ hours of content, covering everything we never talk about on YouTube. What they feared, how they communicated, what hunted them, and much more. Plus an exclusive PDF guide included. Link in the description. See you inside. Humans have the plica semilunaris, a fold of tissue in the corner of the eye that is structurally related to the nictitating membrane but has no sweeping function. It doesn't move. It doesn't cover the eye. It sits in the medial corner, anatomically marking where the full structure used to be, carrying some minor functions related to tear drainage but not the original protective sweeping motion that was the nictitating membrane's reason for existing. If you look at your eye in a mirror and pull the eyelid gently to the side, exposing more of the inner corner, you can see the plica semilunaris, a small pinkish crescent of tissue. That is your third eyelid, vestigial, present, doing roughly nothing that its ancestral form did. The muscles of the external ear, 3 of them, the auriculars, arranged around the outer ear, represent another vestigial muscle system that many people can demonstrate in limited form without realizing what they're doing. Most humans cannot meaningfully move their external ear. The ears are fixed. But some people can make their ears wiggle slightly, and if you're one of those people, you've probably deployed this skill at parties to limited but enthusiastic response. The auricular muscles are fully developed, fully innervated, and present in essentially everyone. In other mammals, horses, dogs, cats, rabbits, these muscles are actively essential. They allow the ear to rotate and orient independently, pointing toward a sound source to maximize acoustic reception while the animal's head remains still. A horse tracking a sound can swivel its ear more than 180 degrees without moving its head. This is a genuine, high-value sensory capability. Humans cannot do this, at least not meaningfully. The muscles are present, but the voluntary motor control over them is largely absent. The motor cortex representation for ear movement is reduced to the point where most people simply cannot activate the muscles deliberately. Some people retain enough cortical representation to produce small, involuntary, or partially voluntary ear movements, which is the party trick. In other mammals, this represents full directional hearing control. In humans, it represents an evolutionary anecdote about a sensory adaptation that was deprioritized as human sensory ecology shifted toward vision and language, rather than wide-angle acoustic surveillance. Male nipples are the vestigial structure that inspires the most frequent casual curiosity, because they seem, on the surface, like the clearest possible example of a structure present in one sex without function. The explanation is developmental rather than evolutionary, and it clarifies an important distinction about how evolution operates. Both sexes of humans develop from the same embryonic template during the earliest weeks of development, before sexual differentiation has occurred. The nipples develop during this undifferentiated period. The subsequent development of either a female or male reproductive system, driven by hormonal signals from the sex chromosomes, doesn't eliminate the already formed nipple structures. It simply leaves them in place and doesn't develop the glandular tissue that would make them functional in the female reproductive sense. Male nipples aren't vestigial in the strict sense of lost function through evolution. They're developmental artifacts of shared early embryonic programming. The same program that builds nipples for the female developmental path runs in both embryos because the fork in developmental programming comes later than nipple formation. The cost of maintaining nipples in males is sufficiently low that there's no selective pressure to reorganize early development to exclude them. Removing them would require rewriting the developmental script in ways that aren't necessary. Wisdom teeth occupy a special category of vestigial structure because they are so reliably problematic in modern humans that their vestigial status comes with a substantial ongoing medical cost. These are the third molars, the final set of permanent teeth to erupt, typically in the late teens to early 20s if they erupt at all. The ancestral human diet required much more grinding capacity than the modern diet does. Raw plant material, tough game, unprocessed seeds. These required large, powerful jaws with extensive molar surface area. Ancestral human jaw size accommodated 4 additional molars, the wisdom teeth, without crowding. Archaeological skulls of early Homo sapiens and earlier hominids typically show no impaction, no crowding, no evidence of the problems that wisdom teeth routinely cause in modern humans. The modern human jaw has, over the last several thousand years of agricultural diet, become somewhat smaller. Processed foods require less masticatory force, and the jaw's development is influenced by the mechanical loading it receives during growth. Smaller mechanical loading, somewhat smaller jaw. The wisdom teeth, meanwhile, are still showing up on the same genetic schedule, trying to fit into a jaw that no longer has room for them. The result is impaction, wisdom teeth erupting at angles, partially emerging, pressing against neighboring teeth, becoming infected, affecting a majority of people in populations eating modern processed diets. The surgical removal of wisdom teeth is one of the most common elective procedures performed in developed countries. Tens of millions of people have had them out. The recovery is unpleasant. The procedure is expensive. All of it is the consequence of maintaining genetic programming for teeth that a changed diet and changing jaw size have made architecturally problematic. Some populations show reduced wisdom tooth prevalence. East Asian and indigenous American populations have lower rates of wisdom tooth development, possibly reflecting more recent selection against their development due to jaw size constraints. The evolutionary removal process is, in these groups, actually underway, just not complete. The sinuses, the paranasal sinuses, the maxillary, frontal, ethmoid, and sphenoid sinuses are air-filled cavities in the skull bones around the nose. Their function in humans is imperfectly understood, which is itself revealing. Proposed functions include lightening skull weight, humidifying and warming inhaled air, contributing to resonance of the voice, and serving as crumple zones for facial impact. Some of these functions are real, others are contested. What sinuses are spectacularly good at is getting infected. Sinusitis, inflammation and infection of the sinuses, often following respiratory illness, is one of the most common reasons people visit physicians in developed countries. The drainage anatomy of sinuses is, charitably described, suboptimal. The maxillary sinuses drain upward, against gravity, through an opening near the top of the sinus, meaning that when the sinus fills with fluid, gravity works against drainage rather than assisting it. This design, which a plumber would find objectionable, is the result of sinuses that were designed for a quadrupedal skull orientation being used in a skull that became vertical through bipedalism, without the drainage anatomy being adequately redesigned for the new orientation. The sinuses are a partial vestige of ancestral skull architecture that has been functionally compromised by the postural changes of human evolution. They exist in their current form partly because the genetic programs that build them are deeply embedded in skull developmental pathways and resistant to modification, and partly because they confer enough ancillary benefit, lightening, some humidification, some resonance, that they haven't been selected against even though their drainage geometry is genuinely poor. Body hair itself, distributed across the human body in the reduced form that remains after evolutionary regression from the thick coat of ancestral primates, is a distributed vestigial feature. The follicles are present across most of the body surface, producing hair that serves limited thermoregulatory or protective function in most locations. Leg hair, arm hair, torso hair, these are maintained in reduced form, neither elaborate enough to provide the insulation and protection of ancestral primate fur, nor absent enough to be clearly eliminated. The human body is caught in a middle state, producing hair from a system built for heavier coverage that has been dialed down but not switched off. The palmar grasp reflex in newborn humans is a behavioral vestige that is both charming and anatomically revealing. A newborn infant, when its palm is stroked, reflexively closes its fingers around whatever stroked it, gripping with surprising strength, strong enough to support the infant's own weight briefly. This reflex disappears within a few months as the developing nervous system suppresses it and voluntary motor control develops. In infant primates whose mothers carry them through arboreal environments, the grasp reflex is not vestigial, it is essential. An infant primate that loses grip on its mother while she moves through the canopy is in serious trouble. The reflex grip keeps the infant attached without requiring voluntary muscular effort that an infant nervous system can't sustain. In human infants who are carried differently and are not navigating tree canopies, the reflex serves no essential function. It is present because the developmental program that produces it predates the human lineage and is still running, activating a behavior that was survival critical in ancestors who lived differently. The Darwin's tubercle is a small pointed thickening of skin and cartilage on the upper outer edge of the human ear, present in some form in roughly 10 to 15% of people. It is a remnant of the pointed ear tip of ancestral primates, the ear shape that allows for better sound directionality, and that is present in more pronounced form in many non-human primates. In the folded human outer ear, this pointed ancestral tip has mostly been folded inward as the ear shape changed, but in some individuals a small remnant of the original point remains visible as a subtle protrusion on the ear's outer edge. It's entirely harmless, does nothing, and serves primarily as a conversation starter for anyone who knows what they're looking at, which is, in a small way, fitting. Vestigial structures are inherently conversational, inherently the kind of thing that opens into questions about where you came from. Here is what all of these structures share, and why they matter beyond their individual novelty. Every vestigial structure in the human body is a timestamp. It marks a point in evolutionary history when a particular structure served a function that the lineage has since moved away from, without completing the process of structural elimination. The appendix marks an era of more herbivorous diet. The coccyx marks an era when tails were useful. The ear muscles mark an era when directional hearing required independent ear movement. The third eyelid mark marks vertebrate ancestors who needed mobile eye protection. The wisdom teeth mark ancestors with diets that required more grinding and jaws that had room for the equipment. These are not embarrassing design failures. They are biological signatures of a history that extends back through hundreds of millions of years of changing conditions, shifting functions, and gradually accumulating modifications. The human body is not a clean design implemented from scratch. It is a heavily modified version of ancestral designs, each modification layered onto what was already there, each vestige remaining because eliminating it was either too costly developmentally or not necessary enough to generate consistent selection against it. Walking around with a coccyx and goosebumps and a plica semilunaris and erector pili and all the rest is not a bug. It's the signature of a process, evolution that builds on what exists rather than redesigning from scratch, that leaves traces of every previous version in the current model, and that produces remarkably capable organisms through an accumulation of modifications that never quite cleans up after itself. You are a palimpsest, a document written over a previous document, with the original still showing through. And honestly, for a document written without a plan, revised continuously for 400 million years, and never once subjected to editorial review, you came out remarkably well. The vestigial parts are just the footnotes.